The centre of mass of objects is very important to how they move and rotate. In this activity, we explore how to find the centre of mass of different types of objects with 1, 2 and 3 dimensions. We start with 1 dimension, as this is the easiest. The technique we use is to find the point of balance, because at this point the centre of mass is above, below, or at the point of balance. For the one-dimensional objects we need some straws, foam, stones or anything we can fit inside the straw. Seal up the ends and then try to find the centre of mass by balancing the straw on your finger or on a stick. If the weight of things you have put in the straw are evenly spread out, the point of balance and the centre of mass will be near the centre of the straw. But if the mass is concentrated near one end, the point of balance will be nearby. We can explain this by saying that each of the things we put in the straw will try to rotate the straw either to the left or the right about the point of balance. When we balance the straw, the moments to the left must be equal to the moments to the right. Now we move on to 2 dimensions. To do this we use a cut-out bird and we will try to move its centre of mass to be at its beak. We will need some paper clips and some coins. First, try to find the centre of mass by balancing the bird on your finger. To move the centre of mass to the bird's beak, we need to add some mass on the opposite side of the bird's beak from the original centre of mass. Try to do it. When you have found the right place for the coins, the bird should balance at the point at the end of its beak, which means that the centre of mass is at the beak or below the beak. Try adjusting the position of the coins towards the tips of the wings and away from the tips, and see the effect on the bird's balance. We can see that when the bird is balanced, the moments from the coins result in a total 0 moment about the point of balance. Because we are now using 2 dimensions, we need to separate into 2 directions when we calculate the moments in x and y, and the moments need to balance in both dimensions. Now we will try to find the centre of mass of some different 2-dimensional shapes. We can cut these shapes out of cardboard, and they can be regular or irregular. The principle we will use is the same as for the 1-dimensional shape. When we balance the shape at the point of balance, the moments to the left and right around the point of balance in each direction will be equal, and the centre of mass will be on a vertical line through the point of balance. It is difficult to support 2-dimensional objects, so we change to hanging them. We make a small hole and support the object from a wire through the hole. The centre of mass must be on a vertical line through the point of suspension. If we make several holes near the edge and repeat the experiment, drawing a line each time, the centre of mass will be where these lines cut. For a regular shape, we can usually guess where the centre of mass will be. Where do you think the centre of mass of these objects is? Does the centre of mass have to be inside the object? Experiment with some different shapes to see. Now we move on to 3-dimensional objects. To find the centre of mass of these objects, we can use the same method as for 2-dimensional objects. We hang them, and we know that the point of suspension must be on a vertical line through the centre of mass. If we repeat this several times, we have a lot of screws sticking into the object, and they all point at the centre of mass. Here the centre of mass is inside the object. We put one screw in the top of the object at the point of suspension, pointing down, and another at the bottom, vertically below the point of suspension, pointing up. Where do you think the centre of mass of this bowl is? We cannot use pins, but we can stick tape and thread on it to hang it. In this activity, we have explored the centre of mass of different things. We have seen that the centre of mass can be either inside or outside the object. This activity should help your students understand the concept of centre of mass, which they can link to their daily lives through the idea that something will fall over if its centre of mass goes outside its base.